Welcome to this video tutorial involving finding lengths of triangles using trig ratios, even if the triangles aren't right triangles. We're going to look at two examples in this tutorial. Maybe you want to hit pause and try this out before we work it through. In this first example, we need right triangles. We cannot use sine, cosine, or tangent without a right angle in the problem. So one of the natural ways to draw in a right angle here is from A perpendicular to BC. We would get the right angle, and then we have two triangles to work with. We'll introduce some variables. Generally, I like to use W, X, Y, and Z. I'll start in the triangle that we'll solve first. It's the one where there's a number for the side. We'll put a W, we'll put an X, put a Y there, and a Z there. That's not quite as important as far as what variable goes where, but being organized is important. So first, we're over in the triangle on the left. We're focusing in on the 51-degree angle. So we could say something like the sine of 51 is equal to the opposite side, which is x, divided by the hypotenuse, which is 46. After all, remember we've got so, ca, toa. So when we're setting up the sine, or so, it would be sine is the opposite divided by the hypotenuse. Now when we go to solve for x, we would multiply both sides by 46 to get the x by itself. And we could go to our calculator and type that expression in. When you go to the calculator, make sure you look in the mode and make sure you are set to degree mode because that makes a difference. So 46 times the sine of 51, that gets us our answer for x. We'll round it to 2 decimal places and we'll get 35.75. And at the same time, we can set something up for W. Now W would be the adjacent side. 46 is the hypotenuse. If we want the adjacent side and the hypotenuse, that would be the A and the H, which would be cosine. So we will set this up as the cosine of the 51 degrees is equal to the adjacent, which is W, divided by the hypotenuse, which is 46. We need to multiply both sides by 46 to get W by itself. So W would equal 46 times the cosine of 51. We turn our attention to the calculator and we'll type in 46 times the cosine of 51, hit enter, and 28.95 correctly rounded to 2 decimal places. That's the first portion of the problem, solving the left-hand triangle. Now on the right-hand side triangle, we found out that x is 35.75. We'll label that in our picture. Ideally, if we could use all of the decimals for x, that would be great. If not, we could get away with using that rounded version at times, but you lose a little bit of accuracy and precision in doing so. So secondly, we will look over at the triangle on the right. We've got the 38 degrees. The x is the opposite. The z is the hypotenuse. That's the O and the H. We will be using sine. So we can start with the sine of 38 degrees is equal to the opposite, which is the 35.75, divided by the hypotenuse, which is z. We would multiply both sides by z, because we don't want that down in the denominator. And then we would divide both sides by sine of 38. Now we would go to our calculator and we would find out what that is equal to. Now ideally, if you don't want to lose any precision, you would like to come back and use that whole decimal. So what we could do is we could say, oh look, we want to use 46 times the sine of 51. Look at the bottom left of your calculator. We can store that as x. And what we could do is we could take that number and divide it by the sine of 38. You would get the same thing then if you took the x, because we've stored it as x, divided by the sine of 38. That gives us our answer of 58.07, correctly rounded to 2 decimal places. And then if we want to solve for y, well, y is the adjacent. We could use the hypotenuse that we just found, or we could use the opposite as well. Let's use the opposite. So we'll go that the tangent of 38 degrees, that's over here, would be the opposite, 35.75, divided by the adjacent, which is y. Now, if you can see how the algebra pans out, I will allow you to jump down to saying that y is equal to 35.75 divided by the tangent of 38 degrees. We'll go to our calculator and we'll evaluate this. Now keep in mind the 35.75 is what we've called x, so we can bring that up. We can say, oh, divide it by the tangent of 38, close your parentheses, make sure you're in that degree mode. And rounded correctly to two decimal places, we would get 45.76. Now ordinarily, in one of these problems, we're not done, because what you're typically asked to find would be the lengths of the sides of the triangle. So AC, that's easy, that's z. We would be able to say, oh, AC is just z, which is 58.07. That would take care of AC. And then we would still need to figure out BC. Well, that's just W plus Y. So we could come up here and say that BC is equal to whatever W plus Y is, and that's the 28.95 plus 45.76. 28.95 plus 45.76 gets us about 74.71. And yes, that's a little bit of work, but it's really not that bad. Break it into parts and then add them up at the end. One more problem we will look at in this tutorial is, now on this problem it's interesting because if we were to draw in the right angle like so, we wouldn't know how the 58 is split up. So on this one, what we're going to have to do is draw in the right angle like this, down here, and then we're going to have to extend this other side so they meet up. And we're going to have to extend this other side here so they meet up. And let's draw that nicely. There it is. We do get our right angle, but now we have to label certain things. There's actually two right triangles. There's the big overall triangle, there's a smaller triangle. So let's go like this, W and X for the smaller triangle. And then just to be clear so we don't forget, I'm going to put a Y like this and a Z like this. So first, we can actually find W to kick things off. We've got the 58, which would be the hypotenuse of the big triangle. So please keep in mind that we're looking at the big triangle, like what is just being outlined in magenta here. So we're going to have W is the opposite, and that's relating to the 21 degree angle. W is the opposite, 58 is the hypotenuse. If we want opposite and hypotenuse, that'll be sine. So we'll say that the sine of 21 degrees is equal to W over 58. Multiply both sides by 58, and W is 58 times the sine of 21. We'll work that out, get our calculator in play, and we go 58 sine of 21, and we're getting 20.78. Now we can store that as W. So if you hit store, you can hit alpha, and then W is above the minus sign. And it will remember that W is 20.79 rounded to two decimal places. Then, secondly, we can get Y on the full triangle. So second, we could look at the cosine of 21 degrees is equal to, now we're looking at the full triangle again, the adjacent is Y and the hypotenuse is 58. So it would be Y over 58. To get the Y, we will multiply both sides by 58. And we'll go back to our calculator. 58 times the cosine of 21, there it is, and we can store that, STO in the bottom left, as Y, which is alpha Y. 54.15 approximately. Okay, so we've got W and Y taken care of. Now we can solve for a couple other variables. We can get X into play. So x comes into play when we're looking at this smaller triangle on the left. We'll do this third. And in that triangle, 180 minus 148 gets us this angle here, which will be 32 degrees. That's kind of important. We know that W is 20.79 from earlier. That's what we figured out over here. Make sure to put that on our picture. And when we're doing this, then we can say that the tangent of 32 degrees is equal to that opposite side, which is W, which we know. We can put the number there, 20.79, divided by x. Now we're getting the hang of this, so when we solve for x, it's going to be 20.79 divided by the tangent of 32 degrees. Go back to our calculator, and we're talking about W. So if I go alpha W, it'll get that full decimal up there for me, and then we can hit divide by tangent of 32. Hit enter, and there it is, 33.26. So x is 33.26. And what we can actually do on our calculator is we can store that value as x. We've got one more thing that we need to solve for, and we need to catch our z's on that. So up here, we're going to solve for z, last but not least, and that'll be the fourth item that we're doing. And what we'll have is that the sine of the 32 degrees is equal to its opposite, which is 20.79, divided by the hypotenuse, which is z. We see that when this shapes up, z will be equal to 20.79 divided by the sine of 32. Now, if you need to show a little bit more work on that, go for it. But if you understand where that's coming from, what I showed is fine. We will now turn our attention to the calculator, keeping in mind that we're starting with w, and we're now going to divide it by the sine of 32. And our answer comes out to be that which we will store as z, alpha z, z is above the 2 key, and 39.22 is that value. Okay, so this is how the problem is shaping up. Now we would need to solve for the missing sides, and that would be the last thing that the problem would require of us. Well, AC we already have. AB is just going to be equal to z in this case, which is 39.22. That's easy enough. And the other item that we need to solve for is going to be the distance from B to C. And if we look at what we have, BC is the whole y minus x. So when we go to our calculator, y, we'll bring up alpha y. That should be the 54.14. Is that what we had in our problem? Yes, it is, 54.14. And then we want to subtract from that the x value that we have. Make sure that we use the correct x value. Yeah, we did. So again, when we took y, subtract x, it turns out to be 20.88. So really how these work is you have to figure out where to draw in the right angle. Look at your picture. Sometimes you might draw it perpendicular to a side and it stays within the triangle. Other times you might draw it outside of the triangle so it becomes perpendicular to a side. But you should end up with two triangles that you're able to work with, and you should be able to work them out with relative ease.